Mars, a planet easily recognizable by its reddish hue, has captivated humankind for centuries. This celestial neighbor, while visible to the naked eye, lies much farther away than our own moon. Imagine Earth as a grapefruit. On that scale, Mars would be a small blueberry, a considerable distance away. This distance, however, does not mean Mars exists in isolation. Like all celestial bodies, Mars possesses its own gravitational pull, a force that can interact with other objects in space, including our planet Earth. While Mars might seem small and distant, its influence can be felt across the vastness of space, even impacting the water that covers over 70% of our planet's surface. Billions of years ago, within the swirling dust and gas of the early solar system, Mars was born. This chaotic environment filled with particles and energy set the stage for the formation of planets. Among these nascent worlds, Mars began to take shape, emerging from the cosmic dance of matter. Like Earth, it coalesced from these primordial materials, gradually accumulating mass and forming a planet. Over millions of years, Mars grew larger, its gravity pulling in more and more debris, solidifying its place in the solar system. Mars, however, followed a different evolutionary path than its larger sibling. While Earth developed conditions suitable for life, Mars took a divergent route, influenced by its size and distance from the Sun. Evidence suggests that Mars once possessed a much thicker atmosphere and possibly even liquid water on its surface. Ancient river valleys and lake beds hint at a time when water flowed freely, shaping the Martian landscape. Over time, Mars lost much of its atmosphere to space, transforming into the colder, drier planet we observe today. The reasons for this atmospheric loss are still a subject of scientific investigation, but it has left Mars with a thin, tenuous atmosphere. Despite these changes, Mars remains a dynamic planet with evidence of geological activity. Volcanic regions, tectonic features, and shifting sands all point to a world that is still evolving. Its surface, a tapestry of craters, volcanoes, and canyons, hints at a turbulent past. These features tell the story of a planet that has experienced significant geological upheaval. While its two small moons, Phobos and Deimos, continue to orbit, forever bound by the planet's gravitational pull. These moons, likely captured asteroids, add to the mystery and allure of Mars, a planet that continues to captivate our imagination. Gravity, a fundamental force in the universe, dictates how objects interact with one another. It is the invisible force that pulls objects towards each other, giving weight to physical bodies and causing them to fall towards the ground when dropped. Imagine holding an apple in your hand. You feel its weight, the force it exerts downwards. This sensation is due to gravity acting upon the apple, pulling it towards the earth. That force is gravity, pulling the apple towards the center of the earth. When you let go, the apple accelerates downwards, demonstrating gravity in action. Now imagine the Earth as a giant magnet and all the objects on it, including us, as small metal objects. This analogy helps us understand how gravity works to keep everything anchored to the planet's surface. The Earth's gravity is what keeps us grounded, pulling us towards its center. Without this force, we would float away into space, unable to stay on the ground. Similarly, the Sun's immense gravity holds our planet and the other planets in orbit. This gravitational pull ensures that the planets follow a consistent path around the Sun, maintaining the structure of our solar system. The strength of gravity depends on two things: the mass of an object and the distance between objects. The more massive an object, the stronger its gravitational pull. Larger objects have stronger gravitational pulls. For instance, a planet has a much stronger gravitational force than a small rock. That's why the Sun, being the largest object in our solar system, exerts the strongest gravitational pull. Its gravity is what keeps the planets, including Earth, in their orbits. However, the farther away an object is, the weaker its gravitational pull becomes. This is why astronauts experience microgravity when they are in space far from the Earth's surface. While Mars might not be the largest planet in our solar system, its gravitational pull still exerts a force on nearby objects, including Earth. This force, although not as strong as that of the Sun or the Moon, plays a role in the delicate balance of our solar system. This force, though weaker than that of the Sun or even the Moon, is not insignificant. It contributes to the intricate dance of celestial bodies, influencing their paths and interactions. Imagine two ships sailing on the ocean, one much larger than the other. The larger ship represents the Sun with its immense gravitational pull, while the smaller ship symbolizes Mars. Even though the smaller ship is far away, the wake it creates can still cause the larger ship to rock slightly. This analogy helps us understand how Mars, despite its smaller size and distance, can still have an impact. In a similar way, Mars's gravity can cause subtle but measurable effects on Earth. These effects might not be immediately noticeable, but they are there, influencing our planet in ways we're still discovering. The distance between Mars and Earth is not constant due to their elliptical orbits. This varying distance means that the gravitational influence of Mars on Earth changes over time. When Mars is closer to Earth, its gravitational influence is slightly stronger, and when it is farther away, its influence is weaker. This ebb and flow of gravitational forces is a fascinating aspect of our solar system's dynamics. Understanding these interactions helps scientists predict planetary movements and their potential effects on Earth. Mars, with its unique position and characteristics, continues to be a subject of great interest and study in the field of astronomy. Section 5. Tides and Currents, Earth's Oceanic Dance. Earth's oceans are in perpetual motion, driven by a complex interplay of forces. Tides, the rhythmic rise and fall of sea levels, are primarily caused by the gravitational pull of the Moon and the Sun. Imagine the Moon's gravity as an invisible hand gently tugging at Earth's oceans. This tugging force is strongest on the side of Earth facing the Moon, causing a bulge of water, or high tide. Ocean currents, on the other hand, are like vast rivers flowing within the ocean, driven by wind patterns, temperature differences, and the Earth's rotation. These currents play a crucial role in regulating Earth's climate by distributing heat around the globe. Section 6. Mars and the Tides, a gentle pull. While the Moon and the Sun are the primary drivers of Earth's tides, Mars's gravity can also contribute to this rhythmic dance of the oceans. The effect is incredibly small, far less than the influence of the Moon or the Sun, but it is still measurable with sensitive instruments. Imagine dropping a pebble into a still pond. The ripples it creates will eventually reach the edges, even if they are barely perceptible. Similarly, Mars' gravitational pull can cause subtle fluctuations in Earth's tides. These fluctuations are most noticeable when Earth, Mars, and the Sun are aligned, combining their gravitational forces. However, these combined forces are still dwarfed by the Moon's influence on Earth's tides. Section 7. Exploring the depths, historical studies of ocean currents. For centuries, scientists have studied Earth's oceans, mapping their currents, measuring their depths, and unraveling the complex forces that govern their behavior. Early oceanographers relied on rudimentary tools, such as drift bottles containing messages, to track the movement of currents. As technology advanced, so did our understanding of the oceans. Sophisticated instruments such as sonar and satellite imagery now provide detailed information about ocean currents, their temperatures, and their salinity. While historical studies of ocean currents have primarily focused on factors like wind patterns and Earth's rotation, the influence of other celestial bodies, including Mars, has also been a subject of scientific inquiry. Section 8. The bigger picture, climate and gravitational interactions. Earth's climate is a complex system influenced by numerous factors, including solar radiation, atmospheric composition, and ocean currents. The interplay of these factors determines global temperature patterns, weather events, and the overall habitability of our planet. While the gravitational influence of Mars on Earth's oceans might seem insignificant, it highlights the interconnectedness of celestial bodies and the far-reaching effects of gravity. Even subtle gravitational interactions can have ripple effects on Earth's climate system. Understanding these interactions is crucial for developing accurate climate models and predicting future climate trends. By studying the delicate balance of forces that shape our planet, we gain a deeper appreciation for the complexities of the natural world. Section 9. Conclusion, a cosmic connection. From the rhythmic dance of Earth's tides to the vast currents that circulate through its oceans, our planet's watery realm is a testament to the power of gravity. While the Moon and the Sun exert the strongest gravitational influences on Earth, even distant Mars plays a subtle role in this cosmic ballet. The study of these gravitational interactions provides a glimpse into the interconnectedness of celestial bodies and the far-reaching effects of fundamental forces. As we continue to explore the cosmos and unravel its mysteries, we gain a deeper appreciation for the delicate balance that sustains life on our planet and the profound influence of gravity on the universe we inhabit.